What if reality is not fully settled until something measures it, and what you call a solid fact begins as a cloud of competing possibilities waiting for an interaction to force an answer? That sounds like philosophy, but it comes from one of the deepest fractures in modern physics, a fracture that still divides laboratories, textbooks, and the basic story we tell about matter. At the quantum scale, particles do not behave like tiny marbles moving through pre-written routes, carrying fixed properties from start to finish the way everyday intuition tells us they should. They behave like possibilities spread across several outcomes, and measurement seems to force one actual event out of many potential events that were mathematically allowed only moments earlier. In 2007, Vincent Jacques and colleagues published a delayed choice experiment in Science, and it became a modern landmark because it tested Wheeler's unsettling question with real optical hardware. Their setup showed that light could reveal wave-like or particle-like behavior depending on a measurement choice made after it had already entered the apparatus and started its journey through it. That does not mean human thoughts magically control the universe, and it does not give science permission to drift into mysticism or fantasy about mind power shaping atoms by intention alone. But it does mean the smallest layer of reality resists the simple story that objects always carry fixed properties before measurement, fully formed and merely waiting for us to uncover them. To understand why this remains so disturbing, we need to return to the older experiment that first broke the classical picture and forced physicists to accept that the observer's question matters. Fire electrons or photons through two narrow openings, and they form an interference pattern on the screen, a signature that looks exactly like overlapping waves rather than separate little bullets. Try to detect which slit each particle actually uses, and the interference pattern disappears, as though the system answers a different reality when the apparatus asks a different kind of question. The particle seems to change what it is allowed to show, not because it has moods, but because quantum theory ties observable behavior to the full measurement arrangement around it. This is the heart of the measurement problem, not the question of what matter is made of, but the harder question of how possibilities become one irreversible fact in experience. Physicists call the spread of possibilities a wave function, a mathematical description of what could happen, where different outcomes coexist in calculation until an interaction selects what is observed. A measurement does not just read that spread like a thermometer reads temperature or a ruler reads length, because the act of measuring becomes part of the event itself. In standard quantum theory, measurement changes the kind of description we are allowed to use, moving from a spread of amplitudes to a definite recorded result on a detector. Some interpretations say collapse is a real physical event, while others say decoherence only makes one branch appear classical, to observers embedded inside a much larger entangled system. Decoherence is powerful because it explains why tables, planets, and bodies do not look like ghostly superpositions, even though their microscopic ingredients obey quantum rules underneath the surface. Once a quantum system becomes entangled with its environment, interference becomes effectively impossible to recover, and the clean quantum alternatives get washed into the noise of the wider world. But decoherence does not fully answer why one experienced outcome is the one we actually get, instead of explaining only why the alternatives stop interfering with each other. That unresolved step is why the measurement problem still survives inside journals, conferences, and fierce disagreements between interpretations that otherwise use the same equations to predict experiments. Mainstream physics does not say consciousness is required to collapse the wave function, despite how often that claim appears in popular culture, internet arguments, and videos chasing mystery over clarity. Most physicists treat measurement as an interaction between systems, detectors, and environments, not as a magical act of awareness, because the experimental evidence supports machinery before metaphysics. And yet the discomfort remains, because the universe seems less like a finished machine and more like a process that crystallizes through interaction, record, and irreversible physical correlation. You feel a distant echo of that every time a decision, a diagnosis, or a message turns uncertainty into one irreversible fact, and life suddenly narrows from many futures to one.